Welcome, everyone. Thank you for listening to another Silicon Labs product podcast. Today, I'm excited. We're joined by Max Palumbo. Max is actually the vice chair of BLE Mesh Working Group, and he used to be a former coworker of mine. So I'm glad to have you on the call with us today, Max.
It's great to be here. Always nice to chat with an old friend.
Well, now you're at Katera, and it looks like you're working on a lot of different wireless control systems, some being lighting and HVAC. So you're definitely involved in evaluating protocols, which is really what we're going to do in the next couple podcast episodes. What we're going to do is we're going to explore some of the protocols that Silicon Labs supports. So I thought it was great with your experience with the working group to discuss a little bit about Bluetooth Mesh. So Max, because of that involvement, you'll be able to provide a lot of good insight for our listeners. So are you ready to go?
Yeah, I'll do my best. Let's get started.
All right, well, so just to start, with all of the other wireless options out there for connectivity, why is Bluetooth Mesh getting attention right now? And maybe what are some of the main benefits of Bluetooth Mesh?
Yeah, that's a really great question. I mean, there's a lot of different protocols out there to choose from, and the reality is that as a product designer, you could make any protocol work to solve the problem that you're trying to solve. Really picking the right protocol is about designing the most optimal product for your use case. I can talk a little bit about some of our decision-making processes and what was important to us and why that steered us towards Bluetooth Mesh away from other protocols. Bluetooth Mesh in general has been designed and optimized around sending very small, very highly optimized control messages back and forth between devices, and doing so with extremely low latency in a very highly congested RF environment. So given that that was the design philosophy of Bluetooth Mesh, if that overlaps well with your application, that's a good use case for Bluetooth Mesh. If you're doing something where you need to send, tens or hundreds of kilobytes of devices, if you need something with very high bandwidth, if latency is not an important design parameter for you, Bluetooth Mesh probably isn't going to be the right solution. For us in our lighting control system, there's a lot of human-machine interaction that says that lighting in particular has to be quite low latency in order to have a good user experience. So that was one of the main drivers for us to select Bluetooth Mesh. The other thing about Bluetooth Mesh that's really nice is that from a network topology standpoint, it's a very flat hierarchy of devices. So really you have nodes that can be relays or not, and you have low power nodes which have to have a friend on the network. It's very similar to a lot of other protocols that use a child-parent scheme, where the parent is the always-on device that will queue up message for the child as a low-power device that checks in at some deterministic polling interval to see if there's any messages for it. And in Bluetooth Mesh, that's pretty much it. And for us, that was a really nice thing because we didn't have to worry about designing a hierarchical family of products. So we didn't have to pick, okay, this one's the coordinator and it has to have this set of flash and RAM requirements in order to do routing correctly, or this guy we plan to be a leader, or anything like that. It's a very, very flat networking topology, and there's no single point of failure like in other mesh protocols. That was another big reason why we selected Bluetooth Mesh. And then the final point is that really all cell phones and laptops and tablets in the last 5 years have gone to market with the Bluetooth radio. So it means that any smart device within range of your Bluetooth Mesh network can join that network. You don't need to have an IP bridge to talk Ethernet or cellular or Wi-Fi to whatever your low-power mesh network is. Most smart devices can tap into it directly. So in thinking about, why Bluetooth Mesh and why it's gaining traction, I would say those are some of the main reasons why we made the decision, and that seems to be a pretty common theme in the market.
Okay, that's great. So you mentioned, you started to talk about how latency and small packet control packets is a sweet spot for Bluetooth Mesh. Maybe talk on the opposite side. What are other issues that might prevent people from selecting Bluetooth Mesh? What doesn't Bluetooth Mesh do particularly well?
The main thing that I think implementers are going to struggle with is that Bluetooth Mesh is really designed, again, for those small, highly optimized control messages to be sent back and forth. If you need something with a lot of bandwidth, Bluetooth Mesh probably isn't the right protocol. A really good example of that would be audio. So if you're building an audio product, like you want to build headphones or speakers or something where you're going to stream relatively large amounts of data, I'm thinking in the hundreds of kilobytes type of range, to a device or multicast that out to many devices, that is not a Bluetooth Mesh use case at all. Those are the types of scenarios where you're going to see the performance of the network be really bad, and you're not going to have a good time implementing that with a product.
All right, that's great. That's a great example. Okay, well, now moving on. So now you've evaluated Bluetooth Mesh, or if one of our customers you're evaluating Bluetooth Mesh. You're obviously going to have some initial challenges, or things that you need to work on when you start to implement Bluetooth Mesh. What were those things for you? What did you find to be the initial challenges to get started with really evaluating Bluetooth Mesh?
Yeah, that's a really good question. I mean, Bluetooth Mesh is still relatively young as far as mesh networking technologies go, compared to things like Zigbee, which have been around for 12, 15 years, Z-Wave, which has been around for, probably an equivalent amount of time. Not really my area of expertise, so compared to some of those technologies that have a really robust history of deployment, the main challenge with Bluetooth Mesh is that the industry expertise on how to interface with this technology isn't there. And some of the work that I've been doing with the Bluetooth SIG as a chair of that working group has been really focused on some of that. So the challenge, at least that we faced at Katera trying to get up and running with Bluetooth Mesh, is that it was designed to be a very flexible protocol. So you can optimize it for very small networks with a few number of hops, very large networks with many hops. You can do things with subnets. You can have different security domains for different parts of your network. And there isn't really any guidance that's given on, if I'm building a small network of, one light and two switches, how should I set those parameters? So there's a lot of there's a lot of intuition you have to build. I think that's the right word on how to configure your network. In general, Bluetooth Mesh, more so than a lot of other protocols, is designed to be centrally managed and configured by the configuration manager node. And you can take a network that would otherwise be very well optimized and would perform quite well, and you can configure it badly and get horrific performance. So that's definitely the biggest challenge, I would say.
So one of the benefits being flexible is also one of the biggest things you struggle with is it allows you to do so many things. You can get yourself into trouble defining exactly what you want to do.
Yeah, and even before the configuration step even comes up, there's a lot of those parameters you have to pick as a product designer. Like there's one in particular that we talk about a lot in the Mesh working group, which is the replay protection list. So maybe to describe what that is a little bit, in Bluetooth Mesh, every node maintains a list of tuples, essentially, of the source address, destination address, and sequence number of the last message that it saw that had that combination of things. And every time it sees a message with a new sort of tuple of those things, it adds it to the replay protection list. And the reason you do that is, if you can infer from the name, to prevent against replay attacks. So somebody from recording a message and then sending it later. If the sequence number is the same or lower than the last message I saw from that source destination pair, then I just reject the message. Given that a lot of these devices are small, embedded devices with a finite amount of flash and RAM, these lists are not infinite in size. As a product designer, you have to select what should the size of my replay protection list be. And it's one of those very tricky parameters to get right, because you want it to be big enough that some reasonable subset of nodes in your network can communicate with each other. If it's too big, then you start to increase the cost of your product by needing more flash and RAM. The drawback of it being too small is that the way the protocol is designed, if your replay protection list is full and you see a message from a new destination pair, you just drop the message. So the behavior that looks like is I add a new device into my network, I start playing with it, and it doesn't actually do anything, even though it's configured correctly and it would otherwise function exactly the way it's supposed to. Everything else in the network has no room left to perform replay protection. So for security reasons, you simply ignore those messages. And that's a really difficult thing if you don't have really good understanding of the mesh specification. It's not intuitive why you're seeing that behavior. And that's one of a couple of different parameters that are relatively important to select correctly to get good performance. The other ones that really come to mind would be things like the default TTL value, which says how far a packet can hop through the network. When I'm configuring the network, what devices do I choose to make relays? What devices do I choose to make proxies? So that's definitely the hardest thing about getting started with Bluetooth Mesh, is you have to build a lot of that expertise in-house in order to know how to configure the network to get good performance.
Well, it sounds like you're on top of getting that straightened out. I'm sure you deal with it on a daily basis at Katera. So now you mentioned a little bit about flash and RAM and the software support. Can you just give a high level? What have you found working with Silicon Labs as far as supporting Bluetooth Mesh? What is Silicon Labs? What have you seen them provide as far as support for Bluetooth Mesh?
Yeah, the support so far has been pretty good. Excellent, actually, I would say. One of the main reasons we chose to work with Silicon Labs is that they were first to market with Bluetooth Mesh. From what I recall about the history of the press release between number 1 and number 2 to market was like an hour's difference. So I don't actually remember who sent it out first, but I mean, whatever. They were first to market for all intents and purposes. And also, for all intents and purposes, Silicon Labs had chosen to implement the features that we cared about most. So those features being low power node support and the models that we needed at the time. Now, that's not to say Silicon Labs has implemented every single feature. There's a lot of optional features in the mesh profile spec and the mesh model spec. And I'm not aware of any manufacturer that has shipping software which supports every feature, at least at the moment. So the decision-making process for us was to pick the manufacturer who had the most coverage of the features we needed.
Makes sense.
Yeah, and the other thing, too, is that, and I'm fully willing to admit that I'm biased in this perspective because I used to work at Silicon Labs, but Silicon Labs has a lot of really good expertise on mesh networking in general. So there's a lot of software tools that are very powerful for us to help, sort of back to the previous question about how do we pick all these network parameters. Tools like Network Analyzer have been really valuable for us. So we actually built a full test network in a warehouse in the back. It's in a building setup that we have there. So we bought, I think, 30 of the Blue Gecko evaluation kits and hooked them up into an Ethernet switch. And we've got a whole test infrastructure there of a moderately sized Bluetooth mesh network that hooks into Network Analyzer, and we can see all the packet traffic on the network through this tool. And that gives us a pretty powerful means of configuring everything the way we need to. We can automate it to the point where, okay, let's try this, and that kind of worked better. Let's try this. Oh, that was really terrible. Let's not do that, and hone in on the right values of those parameters that we need to pick. So aside from the software features, development tools were also a pretty big part of it.
Yeah, I mean, Network Analyzer, the ability, like you said, to plug into Ethernet and get that wired visibility into all your nodes, and sort of analyze it using wired so that you can optimize your wireless connectivity is always very, very popular with our customers. So it's great you brought that up. So that's good for this episode, Max. Can you just, being in the working group and being familiar with Silicon Labs, where would you suggest the first place somebody should go to learn more about Bluetooth Mesh? Are there some good resources that the working groups put together? Anything from Silicon Labs you can suggest?
From a working group standpoint, if you're interested in learning more about Bluetooth Mesh, I would say download the Mesh profile spec. That's a really good description of sort of how the network functions. It's pretty long. It's about 400 pages, and that might seem daunting as a starting point, but there's a really good section at the start. Section 3 is like a high-level summary of how everything works. That's only about 30 pages long, I think. That's, if you're planning to do Bluetooth Mesh, I would consider that mandatory reading because it goes over all of the really key architectural components of the protocol. As a product implementer, you probably don't need to know too much more about how the network itself functions because you get APIs to deal with all that stuff. The other piece of reading I would suggest is the mesh model specification. So that's really the application layer is a good way to think about it. The models and the messages that they can send are going to be how your products interface with each other on the network. So understanding how those work and how you can use those to solve your problem would be a really good starting point. In terms of Silicon Labs specific stuff, I always forget the names and numbers of the documents, but there's a quick start guide or something. It might be a user's guide, but it's how to set up a sort of two-node network where you build a light bulb and a light switch. Pretty good starting point because it goes over a lot of the really key care-abouts with the tools, like how to download the SDK, how to create the project, building your node composition, using the automatic code generation features to create all that stuff, and then compiling and running the code. So if you can find the Bluetooth Mesh light switch getting started guide for the Blue Gecko module, that would be pretty good reading as well.
All right. Well, hey, this has been very, very helpful, Max. I really appreciate you taking the time to help our listeners. I'll put some of the links in the description of the podcast for people to quickly access the user's guide and then the Bluetooth working group document so that they can reference that. But again, thank you for taking the time, Max. I appreciate it.
For sure.
Yeah.
Before we sign off here, there's one other comment I would like to make. I would be remiss to forget about this, but if you're planning to build a Bluetooth Mesh product, you have to get at least adopter level certification with the Bluetooth SIG. And normally you have to be an associate level member to join the working group. However, recognizing that there's another committee within the Bluetooth organization. It's the Smart Building subgroup. That's open to associate adopter members. And joining that group would give you sort of advanced access to new features that are coming down with Bluetooth Mesh. And it would be a really good forum if there's something that's missing from Bluetooth Mesh or something you would like changed or something that you would like added to the protocol. That would be a really great vehicle to start voicing some of those opinions and getting requirements put into Mesh 1.2 and 1.3 and 2.0. That's open to adopter members, and since you have to get at least adopter level status with the SIG anyways in order to ship the product, there's definitely a benefit to joining the Smart Building subgroup. It's a once-a-week conference call, Wednesdays at, I believe, 11 o'clock Central Time. One of your colleagues in Germany actually is the chair of that group, so Silicon Labs definitely has a lot of extra information they can share once you've joined that group. as well.
All right. Well, thanks, Max, again. And thanks to our listeners. Stay tuned for more podcasts from people like Max, and we'll do some other podcasts on different protocols so that you can learn more about information just like what Max shared about Bluetooth Mesh. So thanks again, Max.
Yep. Thank you.